All right, guys, we'll move on to question 3A. It says the diagram below shows two pentagons, P and Q, drawn on a grid made up of squares. Now, pentagon meaning that they have 5 sides. So P and Q both have 5 sides. And by looking at P and Q, there are certain things that you can start taking note of, such as P and Q would appear to be the same size. Okay, all right, that's one important, the same shape and same size. All right. It says select the correct word from the following list to complete the statement below. And you have opposite reflected, congruent, translated. Pentagon P is dashed to pentagon Q. Now, if it is reflected, one would be laterally inverted, all right, which is not the case here. The orientation has changed. This has turned completely. This doesn't reflect lateral inversion, all right? And normally when it's reflected, you can bend it on a line of reflection and they overlap. This, of course, wouldn't happen. Translated, translating would mean that it maintains the same orientation. And so that's out. Opposite. Opposite doesn't necessarily make any sense right here, right? Because when two things are opposite, they're completely different from what each other are. So that's out. So the only logical term here is congruent. And what does congruent mean? Congruent means that they have the same shape and the same size. So it's congruent, C-O-N-G-R-U-E-N-T. All right, so that's the term I would use to define them. Now, of course, there's a follow-up question now that says, give the reason for your choice, right? Why are they congruent? All right, congruent means that they have the same, so you can say they have the same shape and size. They have same shape and size. Hence, the both of them are congruent. All right, so that basically sums up what is happening there. And of course, that would look more like, if you go back to the diagram, that's more like a rotation. Okay, let's go down a bit now. Question B says the diagram below, not drawn to scale, shows a pentagon VW XYZ. In the pentagon, YZ is parallel to XW. And of course, you can see the parallel symbols on both sides. All right, you have angle XYZ equal to 114 degrees, while angle VZY is equal to 98 degrees. Now, we can see several parallel things happening here. So for me to better understand this, all right, so I'm going to extend this line outwards. If you want, you can extend this line. You can extend this line. You can extend this line right here. You can extend that line. You can extend this line. Now, what's the reason for extending these lines? Now, of course, the moment you extend the lines, you start to see some angles that are related, like what you call corresponding angles, where you're looking for your F. So what it means is that, let me put this in blue. This angle over here is corresponding to 114 degrees. So this is also 114 degrees. Persons normally remember it by calling it the F angle, right? So because it basically forms an F, you can see right here. Those parts would be the lines on the F, and the straight line down here would be your F. So I know that's 114 degrees. Now, in terms of finding WXY, so WXY. So this is the angle here that I'm interested in. Now, of course, angles at a point on a straight line measures 180 degrees. So this would be equal to 180 degrees minus 114 degrees. All right? So that simply boils down to 80 minus 104. This will boil down to 66 degrees. As you can see, right? Not so bad. Angle ZVW. So ZVW. So right now, I want to find this angle right here. What's the size of this angle? Now, let me put in what I know. I know that this is 66 degrees, all right? Now, if I extend this line as well, all right, so this is where it gets interesting now. If I were to also extend this line, you can look at this now as another F angle. All right, so it means that up here would also be 114 degrees. Good. Now, we have what is called, if you look at this here, well, the corresponding angle is basically your F angle, right? It forms an F, as you can see right here. If you take this line, there goes your F. Now, we also have what we call vertically opposite angles, and those are the angles found in an X. So if you look here, this is my X, and these will be the opposite sides. In fact, let me put a red to highlight the X so you can see clearly. So like that, and you go like this, you have an X. So the angles on opposite sides are equal, which means right under here would also be 114 degrees. There's a different way we could have done it. We could have used what is called alternate angles. We also call them Z angles. So here's the Z. I'll put that in red as well. There we go. We have our Z angle. So that's the next reason. So there's a lot of different ways you can look at it. All right, so you have 66 degrees, which is right here. You have your 98 degrees, you have your 14 degrees. Now, this is what you call a pentagon, 5-sided polygon. Now, the question is, what is the sum of the angles inside of a pentagon? All right. There's a little formula that you can use to remember the sum of the angle inside any polygon. It's n minus 2 times 180. So in terms of a pentagon now, a pentagon has 5 sides, all right? So it's gonna be 3 times 180, because 5 minus 2 is 3. 3 times 180. Now if we multiply 3 by 180 degrees, I'm gonna get 540 degrees. So to find that angle up here, let me just scroll up back a bit. To find ZVW, I just need to add up all these angles and subtract them from 540. So we have 98, 114, 114, and 66. So this is going to be 540 minus 98 degrees plus 114 degrees plus 114 degrees plus 66 degrees. All right? You could have said 114 degrees times 2. Of course, all that is calculator work. Now, don't forget to put your bracket. That part is important. In fact, let me make sure that I bring up my calculator so we don't go wrong on that. In the meantime, all right, so let me just pull this down so you can see everything. So I'm going to have 540 degrees minus, open bracket, I'm going to have 98 plus 144 plus 144 plus 66, all right? That's going to give me 88 degrees. So this is 88 degrees. So ZVW is equal to 88 degrees. All right, so ZV, just put that there, equal 88 degrees. And that will be the end of that question. All right, so let me take. All right, for C, it says the letter A and a point C66 are shown on the grid. All right, so you have letter A and you have the point 66. It says on the diagram, draw accurate each of the following transformations. The enlargement of letter A by scale factor 2 and center C66. All right, now there's a lot of ways to do it. You can actually use your ruler to know that the distance of the object from the center is half the distance of the image from the center. In other words, the distance of the image from the center is twice the distance from the object to the center. All right, so if you have a ruler, let me just pull up a ruler quickly. Let me move this here. So you could use your ruler to measure the distance from the center to A. And let us say that that distance is 2 units. Hypothetically speaking, there are no units on my ruler, so I'm just saying 2 units. It means that the distance from the center to the object, to the image, sorry, would also be 2 units. All right, so that same distance that you see there, let me just indicate from here to here, that distance would be the same from the object to the image. So it would take me down to this point right here. Good, but because there are no units on my ruler, it's going to be tricky to use my ruler. But of course, you only need your ruler to measure that distance and you're going to get it, right? So I know that this distance will be the same. So I'm going to put the tip of the A right here. Okay. All right, the same concept would apply to all the other parts of a letter. So we just need to get the edges. Once we get the edges, then of course we're good to go. All right, so you can use your ruler again to line it up and measure the distance and make sure that the distance is the same. All right, I'm just going to pull this up here. All right, we're going to do the same thing with each point. So we're going to take the ruler and we're going to line up the center with a point on the A. We're going to check that distance. Now, what we have to do is that we ensure that if distance is 3, we also have to make the distance from the A to the image 3 as well. Or we make the distance from the center to the point 6, which is double. So the distance of the object from the center is half the distance of the image from the center. So if this distance is 3, we have to make the distance to the object, to the image, 6. All right. So when I check that, the next point, this point right here is going to come to 4, -2 right there. And the point here, if we use a ruler, is going to go to 0, -2. All right, so you just take the ruler, you measure the distance from this point over here to the center of enlargement. Now, the reason why we are making the distance double is because of the scale factor. The scale factor is 2. All right, so you set your ruler as best as possible. There we go. And you can see that that distance from 0, -2 to 6, 6 is double the distance from 3, 2 to 6, 6, right? Because we're looking at both distances. All right, with that said, now I can go right ahead and I can draw my A. So let me just get this in right away. So I'm going to get my shape. And I'm going to draw from this point here down to where this point is. All right. I'm also going to draw from this point here down to where that point is. Not so perfect, but as best as possible, right? Then of course you'll want to notice now that this line right here is actually in the center of the A. So you could do the same concept with that, but it's not necessary because it's right in the center of the A, which means it's going to fall right on this axis right here, going across. All right, so that's my A. That is when we carry out the enlargement. So we're supposed to do an enlargement, and then of course we are supposed to do a translation using -2, -3, 2. So with the translation, pretty straightforward. The image is going to remain the same size and shape as the object. All right, all we're doing is that we're adding each point on the object to the translating vector, which is -3, 2. Good, so let's get right into it. So here I'm at 4, 4. -3, 2 would mean 3 places to the left and 2 places up. So I'm going to go 1, 2, 3 to the left and 2 places up, 1, 2. So the tip of the A will be right here. We'll do the same thing for these points. So I'm going to go 1, 2, 3 to the left. And of course, I'm going to go 2 places up, 1, 2. We'll put this there. The same concept will apply to over here. 3 places to the left, so 1, 2, 3. And of course, 2 places up, so it comes right here. Now, all we have to do is just connect the points on this L. Please use a ruler so you get a straight line. It doesn't look like mine. So that's it. All right, so this is my enlargement down here. Probably we can use E for enlargement. And this is my translation. We can use T up there so for translation. And that will be the end of the thing right here.